Hey there, mathletes. It's Mr. Nolde again. Today we're going to talk about polynomial long division. So polynomial long division is much like long division with ordinary numbers. So let's suppose I wanted to divide 38 by 7. So 38 divided by 7. So if I were going to do long division with this, I would say 38 divided by 7. So remember, this is called our dividend. This is called our divisor, and our answer is going to be called our quotient. So what we're doing is we're taking some polynomial function eventually, dividing it by a divisor function, and we're going to get a quotient function. And sometimes that's going to have a remainder function, and the remainder is always going to be over the divisor. So let me show you how that works out with this 38 divided by 7. So I know that 7 goes into 38, let's see, 5 times. And then we multiply 5 times 7 and write it down here. So 35. Then what do? I subtract. So 38 minus 35 equals 3. And 7 does not go into 3, so I'm done, unless I'm going to put decimals in here, but I'm not. I'm just going to say this is a remainder 3. Or maybe we used big R when we were in class, but this means that 38 divided by 7, well, that's 5 plus a remainder, and the remainder is 3, and it's 3 what? Well, this is important because this will come in with polynomial long division. So 3/7. We could also think of this as 5 plus 3/7. So what we just did there is we said, well, I know that 7 times 5 plus 3 will give me that 38. And we're going to walk through that process with a polynomial in just a second. So here's a polynomial division problem, long division problem. So we're going to take this 6x squared minus 26x plus 12 and divide it by a negative 4. So let's set it up the way we'd set up any long division problem. So x minus 4 becomes my divisor, and my dividend, 6x squared minus 26x plus 12, goes inside, right? Inside the garage, if you remember from 4th grade. So again, we're going to look at well, not again for the first time, we're going to be looking at our leading, what's called our leading terms. So the leading term here is an x, and the leading term here is a 6x squared. So we want to ask ourselves, how many times will this x go into the 6x squared? And the answer is, it'll go in 6x times, because 6x times x gives me 6x squared. So I want these two to be the same so that they can add off. They go to 0. Then I'm going to finish it out with 6x times minus 4. Well, that would give me a minus 24x. So the next thing we did in long division was we subtracted. So I always encourage students, I'm going to do it in a different color. Remember that you are subtracting both of these terms here. 6x squared minus 6x squared, that's a 0, and that's usually pretty easy, but sometimes what happens is we forget to do negative 26 minus negative 24, and we just end up adding these up and getting a negative 50. But we're not going to do that. We're going to do 26 minus a negative 24. So what's minus an, oops, I just erased that. What's minus a negative? Well, minus a negative is a positive. It's adding. So negative 26 plus 24x. So that would give me a negative, oops, I want to switch my color back, give me a negative 2x. Now, if we had a longer number for long division, we would bring down the next digit. So the next term is what we're going to bring down, the 12. And again, we're going to look at the leading terms, x and negative 2x. So how many times does x go into negative 2x? Well, it goes negative 2 times. And I know this because negative 2 times x gives me a negative 2x. So remember, I want these two to be the same. I want those to be the same. Then I'm going to do negative 2 times negative 4. That's going to give me a positive 8. and then I'm going to subtract. But don't forget, we're subtracting both terms here. Okay, both terms are getting subtracted. So the negative 2x minus negative 2x is 0. I don't really have to write that. And then I have a 12 minus 8. So 12 minus 8 is 4. So I have a remainder up here of 4. And it's 4 what? Well, it's 4 x minus fourths, if that's a thing. So I'm going to say x minus 4. So the correct answer is 6x minus 2 plus the remainder of 4 over x plus 4. So what that's telling us, remember, in the context of this problem, is if I take my divisor, x minus 4, multiply it by this part of the quotient, and then add 4, this should be equal to what I started with right here. So let's do that. Let's FOIL this out. X times 6x is 6x squared. My outers are negative 2x. My inners are negative 24x. And last times last, negative 4 times negative 2 is positive 8. And then remember, I have this plus 4 as a remainder. So I'm going to combine my like terms here. So that gives me a 6x squared minus 26x. And these are like terms I can combine. 8 and 4 gives me a 12. And that is exactly what we started with up here. All right. We'll look at one more for good measure. All right, so this time around, we'll take a quartic, fourth degree. So I have x to the fourth, x cubed, x squared, x. So I will not need any placeholders here. I'll show you an example that requires a placeholder next. So an example of this is, well, the way to do this one is write it out like a long division problem. So here we go. X to the fourth minus x cubed minus 19x squared minus 3x minus 19. So again, I'm going to look at these leading terms. How many times does the x go into the x to the fourth? Well, it goes x cubed times. So, and again, I'm going to stack this on top of the other x cubed term, but multiply this x cubed times the dividend of, or the divisor of x minus 5. So x cubed times x, well, that's x to the fourth. That's what I wanted to have happen. And then I have to remember to multiply x cubed times negative 5. So that gives me a negative 5 x cubed. So we line up our terms, and then we subtract. You can use my little trick here. Remember that we are subtracting both of these terms. So it goes x to the fourth minus x to the fourth. That's a 0. Don't have to write it. Then I'm going to take negative 1 x cubed minus negative 5. So that's minus a negative. It's like adding 5. So negative 1 plus 5 gives me 4. Oops, I want to switch that color back. 4x cubed. Then, just like long division, I'm going to bring down my next term, which is minus 19x squared. Then, leading terms. How many times will x go into 4x cubed? It will go in, let's see, 4x squared times. Because 4x squared times x is 4x cubed, and 4x squared times minus 5, that's a minus 20x squared. I'm going to scooch this up a little bit. Subtract. We're going to subtract. Remember, we are subtracting both of these terms here. So they both get subtracted. So what is 4x cubed minus 4x cubed? Well, anything minus itself is 0. I don't have to write that. And then I'm going to subtract 19x squared minus a negative 20x squared. So that's like adding 20. So that leaves me with x squared. Drop the next term down, minus 3x. X up here goes into x squared here, x times, because x times x is x squared, right? We're multiplying x times x, x squared. X times minus 5, well, that's minus 5x. Then I'm going to subtract. Don't forget, we're subtracting both of these terms here. Need to scooch up a little more. Let's see, x squared minus x squared, that's 0, which I don't have to really write. And then I have negative 3x minus negative 5. So that's plus 5. So negative 3 plus 5. That's a 2x. All right, I have one more term to drop here, don't I? The minus 19. Oh, heavens to Murgatroyd. Minus 19. So my x divisor will go into 2x 2 times. So plus 2. Then we're going to go ahead and multiply. So you have 2 times x is 2x. So that's what we want to have happen. We want that to be a 2x. Then I'm going to multiply 2 times negative 5. That's a negative 10. Last step, subtract. Again, eventually you won't have to do this. I'm just doing this to remind you and also remind myself that I want to make sure I subtract both of those terms. So 2x minus 2, that's 0. I don't have to write it. And negative 19 minus negative 10. So that's like adding 10. So that gives me a negative 9. Oops, I just made my divisor my remainder in a wrong color. So let's see. This whole polynomial up here divided by x minus 5 is this polynomial plus, or minus in this case, this remainder. So I'm going to go ahead and write that in. That's minus 9 over x minus 5. And again, this x minus 5 is coming from where? It's coming from right here. So that is this is the quotient with the remainder. So here is an example I just said I was going to show you that requires a placeholder. And I'll show you what I mean by placeholder. I'm looking at my problem here. I'm going to divide 3x cubed plus x squared plus 3 by dividing that by x plus 1. But I notice I am missing an x term here. So I have to put that in as a placeholder in my long division. So let me show you what I mean. It means go ahead and write this like this. X plus 1 goes into 3x cubed plus x squared plus 0x plus 3. So right here, this is my placeholder, and you'll see why we need it in a moment. So leading terms again, x goes into 3x cubed, 3x squared times, because 3x squared times x is 3x cubed, and 3x squared times 1, that's 3x squared. So I'm going to subtract. So anything minus itself is 0. X squared minus, remember we're doing minus of both terms here. So I guess I'll add that in there again for us. And let's see, 1x minus 3x is negative 2x squared. And I will bring down my next term. This is my placeholder term. So now how many times will x go into negative 2x squared? Well, negative 2x times. So notice I have to have this x term here to line them up. So negative 2x times x, that's my negative 2x squared. So I want these two to be the same, right? If these are the same, then they'll add away. And then I'm going to multiply 2x, negative 2x times 1. Real quick again, negative 2x times x was 2x, negative 2x squared. Negative 2x times 1, negative 2x. So I'm going to write that in. Then I'm going to subtract. And if you like this, keep on doing this. This is a little trick somebody taught me. So I'm going to subtract, the first two go away. Anything minus itself is 0, and 0 minus negative, so that's plus 2x. Plus 2, whoops, dagnabbit. Forgot to put my color back. Plus 2x. Final term gets dropped. It's a 3. So x will go into 2x 2 times. So 2, positive 2. Then multiply 2 times x plus 1. 2 times x, 2x. 2 times 1, 2. Subtract both terms. Gets kind of repetitive after a while. And then 2x minus 2x, that's 0. And 3 minus 2 is 1. So there is a remainder of 1. So plus my remainder of 1. And it's 1 over x plus 1. Because this comes from this. It's the divisor. So if I multiplied x plus 1, let's suppose that we could check this, x plus 1 times 3x squared minus 2x plus 2 plus 1, because that was the remainder. When I do that, I end up with the same thing that I started with. It equals 3x squared cubed, 3x cubed plus x squared plus 3. So that checks. So there you have it, sports fans, polynomial long division. Please go ahead and smash the like button if you've gotten value out of this. Go ahead and subscribe. That way you won't ever miss a thing. This is Mr. Nolde, your personal math coach, signing out.